are done with installing everything. Now we can play with the scripts. So you're gonna want to navigate to where your scripts are stored. Mine is a very peculiar area. I'm just gonna move it closer to my C drive. So I'm gonna rename this as data, just data. I'm gonna move it towards just gonna move it into my C drive. The data lives in my C drive. So what you want to do is navigate to wherever your data is stored. So if your data was stored and you click on the, well, if you click on the file explorer, you can see the directory path. Mine's directly on the C drive, so I'm just gonna go to C drive by typing CD or D or just C. So to the home folders, C. So you use CD to navigate and you can be using CD to navigate through directories with Python or the CMD. So you want to where you are on C drive. Well, I'm on the C drive. If you're on a different drive, you're just gonna type in like F colon if I had that, or D colon. Actually, I have a D colon. Oh, C colon. Do that. And so we're directly into C, and what we can do is type C data, that folder. This is where we're gonna be mainly staying on. So one of the first scripts we're gonna write is, or not write, we're gonna run is you run scripts by typing Python find underscore bb dot py. That's this script right here. And before you run it, I suggest typing in dash dash help, and that gives you the parameters that it takes. Which this one doesn't really take parameter except a file name. And that file name that we're gonna put into is video2, vid2.mp4. It's important that you put the extensions. It should run much like the learning toolchain or FTC machine learning toolchain. You're gonna want to draw a box around the object you're trying to detect. In our case, it's a green solo cup. And before you type, actually, you gotta type before you draw it or while you're drawing it. Press in a letter. So I'm just gonna put C for cup. C current class is C. Draw 2 points right here and one here. C. Once you're done drawing your box, you can close out it by pressing Q. Once that's done, you get this labels your points for your C cup. If you have more than if you have more objects, you can label those as well. Once that is done, I'm gonna run. We only run 2 scripts: find BB for tracking the initial bounding, and tracking up pi, which we'll get into right now. Python tracking .py. And let's look at the help for it. So you can see that it takes in the scale, which we're not going to mess with. I wouldn't suggest messing with. The tracker, which could mess with, but it's usually best to, or I find it best to stick with default, but we'll test out a random one. I wanted to know what trackers there are. And we're not going to mess with yes. If you want to mess with the frames, how many frames you're going to label. So how many frames you skip, or to skip to label a frame. So if you skip 4 frames, label every 4th frame. or shift frame. And the experiment we're not going to mess with. So let's just run this with vid2. We have the bounding box ready. So we're going to type in python tracking.py. The file name vid2.mp4. Let's give it every 5th frame, every 10th frame actually. The long video. And let's give it a tracker 4. So you put dash and then the argument HSTF, and then you put your parameter with a space after. There are a total of 6 trackers, I believe, or 7 trackers. It says right here. Press enter, this should work. Yes. So opens up this window. We type in Y, run it. It should track. You see three screens, and right now it's tracking. The camera's not moving because that's the nature of the video. Oh, it's gonna move. So you wanna stop and relabel your box, which all you gotta do is press space, go to tracking, and resize it. So resize that. Press space again to play again. And here you see which frame it's tracking or saving. And see the box. And here you see what the tracker's seeing. So I'm just gonna make this box shorter. Right now I'm only doing it with one object, but you can also do it with 2 objects or 3. I wouldn't suggest going over 10 or even 5 for that fact, because the tracker's pretty dumb. Since I'm going so slow, it's able to track it nicely. Just put this so I can see. So we'll go into it, goes all the way to the edge, and we'll stop it. You can press Q, stop it. That stops all the video. And what this produces is a tab that produces images. So these are all the images that saved the video. See, it's here. And annotations in a Pascal bulk format. So if I open it with Pet, you'll see that tracks the width and height of the video, which if you're creating data, you should use preferably your webcam that you're going to use for competition, and keep it at the same height as the on which you're placing it on the robot, which is what we did with the webcam and recorded a video with it. It tracks the boxes right here. So if you want to do another video, say vid3, what we'd do is python.vid3. Wait, I run the script. Find bb, because we got to put the initial box for that. Vid3. Let's run vid4. MP4. Just gonna track this. Or we gotta put. You gotta put. It's important that you put the same class name. So you press C or C, and it changes it. You're doing different videos. You can press Q to exit. Oh, I should have noted, if you wanted to change the class into a longer name, or you run the tracking, you should change the rex folder or file. Instead of C, you could have put cut, but you should do that before tracking, as the annotation save it as C. So let's run the tracking vid for vid 3. Just gonna change this vid 3. Oh, whoops. Oh, we run vid 4, my bad. Let me press Y. It's gonna track. So we're gonna want to once you train all your data, or once you get all your data, you're gonna want to shuffle your data for training data and then validation data. As the TensorFlow will train with the train data, and it will validate itself with the validation data. So provided a script that will shuffle these between an 80 to 20%, 80% training and 20% validation. You can run that by typing in python that shuffle.py. That should create 2 folders, train and validation. These will have annotations, images, respectively to their data. You can look that will be the same files, 96 here. There should be 96 here. Validation will have less, but still here. So that once we're done with that, we're off to train the data. It's a very simple way to train the data. All I gotta do is go to Google Drive. I'm gonna upload the data first. Go into the drive. For some reason I gotta sign in. So back with that. Okay, once you're into Google Drive, you're gonna want to create a new folder. We're just gonna call it data. In data, you're gonna upload 2 folders we just made. Are on my C drive. Data. We're gonna upload annotations. Now we're gonna upload train. Upload. Take a while. In a minute. We're gonna also upload validation. That's uploading. We can go on to the next step. We are going to go to the TensorFlow Google Colab. I'm going to copy the link for. So we're going to go to the TensorFlow Google Colab. And here we have what we're going to be running training. To run it, you obviously want to, we're going to run the prerequisites first. You can look at okay, we're doing this. Cycles. First try, easy. To run it, we're going to use, actually before you run it, make sure that you're click on runtime and change runtime type and you're on GPU. If you're on TPU, then your training is going to be significantly slower, like hours slow. If you're on GPU, it should take relatively 10 to 30 minutes to train the model. And see that we're on GPU, so it's fine. But we're going to run these. Once that's done running, which it just finished, we're going to run this too. And one tidbit. So, model architecture. If you ever use the machine learning toolchain, know that you gotta choose an architecture. Well, this one, it gives you helpful guide table, but you can read this and see which one fits yours. But for me personally, the light zero is what's usually used. It's much like the SD or whatever is on the first for machine learning. I wouldn't go above 2 because your model gets a bit slow after that. And I find